Drilling cores, like these lined up at the abandoned Khorob mine northeast of Homeb, are extracted from specially designed drilling bits that cuts around rock rather than simply through it. What you end up with is a cylindrical column of rock that reveals the structure and nature of the rock below. These cores can reveal extraordinary detail of the sediments with depth, which is a proxy for time of deposition. These cores happen to have been set for mineral prospecting and were drawn from the rock with a drilling rig mounted on a truck or a derrick. However, drilling rigs can also be mounted on ships, which allows scientists to explore ocean sediments in as great a detail. From these sediment cores, inferences about past climate can be made. Imagine you have a continental landmass drained by a river. One way to infer climate is from the grains of dust and particulates carried into the ocean from this landmass. These can be either wind-blown sediments, also called aeolian particles, carried out over the ocean by onshore winds, or so-called hemipelagic sediments, carried into the sea by sediments from flowing rivers. These then settle onto the ocean floor to build up as sediments. One can distinguish these different types of sediments from particle size. Aeolian sediments tend to be larger than hemipelagic sediments. These can indicate past climates because the relative proportion of these different particle sizes will vary with climate. If there are vigorous water flows in rivers, for example, this indicates higher rainfalls, more flows in rivers, and therefore more hemipelagic sediments. If conditions are drier, aeolian sediments predominate, driven by those strong onshore winds. A core taken from the Walfish Ridge allows one to follow changes of climate over southern Africa over the past 350,000 years, roughly the span of the late Quaternary period, which lasted from roughly 2.6 million years ago to the present. Over the time period covered by this core, the Earth underwent several glacial periods, indicated here in blue, interspersed by interglacial periods, indicated here in orange. It's important to remember that Africa itself did not experience any glaciation during the Quaternary. We live in the latest interglacial period. Here is a representation of the proportion of sediments classed as hemipelagic sediments in dark gray versus aeolian sediments in light gray. Even though the data are noisy, with seemingly no clear-cut pattern, there is a trend toward increased proportion of hemipelagic sediments during glacial periods. From this, one can infer that glacial periods corresponded with periods of increased rainfall over southern Africa, and hence increased runoffs through rivers. Interglacial periods, in contrast, were periods of low rainfalls and strong onshore winds that carried wind-blown sediments over the oceans. From all this, the notion of the Namib as a continuous ancient desert with a purported age of millions of years cannot stand up.